So good morning, all of you. I think you have completed the what what are the portion that is completed yesterday. Okay, so that means we have completed the zeroth law of thermodynamics as well as the first law of thermodynamics. Also, we have completed. Yes or no? So as we completed the first law of thermodynamics, that means the first law of thermodynamics. What does the first law of thermodynamics says that if a q amount of heat is given to a system, if q amount of heat is given to a system, it is used to increase the internal energy of the system and some part of the heat energy. If q amount of heat is given to a system, some part of that particular heat energy, some part of heat energy that is used to increase the internal energy of the system. Okay, internal energy, that means if the internal energy system of before that, the internal energy, if you are taking the u as the internal energy, then the delta u is the increase in the internal energy. Delta u is the increase in the internal energy. Okay, so if the q amount of heat is given to the system, it is used to increase the internal energy of the system plus some work done by the system. That means w, that means q equal to delta u plus w. Okay, so q equal to q means whatever the heat we have supplied to a system, that is used to increase the internal energy as well as the work done by the system. Okay, so this is the first law of thermodynamics. If you want to find out the delta u, how can you find out? Q minus w. Okay, this is the what delta u. Delta u means change in internal energy. Okay, so and if you're just taking that means if you are finding out delta u means what? Delta u means before that, if the system having the internal energy ua. Okay, if a system having the internal energy before ua, and after supplying of heat, the internal energy changes to what? Ub. Okay, so delta u equal to ub minus ua. This is the, that means change in internal energy, that will be ub minus ua. Okay, so that is the change in internal energy, delta u. Okay, so if you are writing in the derivative form, you are writing, then what is the value? dq equal to du plus dw. Okay, dq equal to du plus dw, or if you are finding out du, dq minus dw. In the derivative form, if you are writing this, du is a very small change in the internal energy, and dq is the very small change in the heat energy we have supplied, and dw is the work done. Okay, so that is the equation will be dq equal to du plus dw. Okay, this is the all about the first law of thermodynamics. So zeroth law, what the zeroth law tell? That zeroth law telling about the temperature. Temperature means if the two system A and B are, they are separately thermally equilibrium with the third system C. Okay, so according to zeroth law, A and B are also thermally equilibrium to each other. Thermal equilibrium means what? Thermal equilibrium means if the both the temperature of the two system are same, they then can call as they both the system are in thermally equilibrium to each other. Okay, then how can you apply the first law of thermodynamics? How can you apply the first law of thermodynamics in the different system? That means the different process, thermodynamic process. So first of all, we should know about what is thermodynamic process. There are different types of thermodynamic process. Okay, so what are the different types of thermodynamic processes are there? First one is the cyclic process. First one is the cyclic process. Cyclic process. Okay, definition I have already told you in the yesterday class. What is the definition of the cyclic process? If a system after passing through a different state, if a system after passing through a different state returns to its initial state or original state, then this type of process is called as the cyclic process. We have already found out the work done through a cyclic process. Also, we have already found out. Okay, and then if you are finding out the, if you are applying the first law of thermodynamics in the cyclic process, then what will happen? In the cyclic process, particularly, there will be no change in the internal energy. In the cyclic process, one thing you have to remember in this particular cyclic process, delta U means there is no change in the internal energy. Delta U will be zero. Okay. So in the particular cyclic process, what will happen? Delta U equal to zero. Okay. So if you applying the first law of thermodynamics, applying the first law of thermodynamics. First law of thermodynamics, what does it tell that? First law tells us Q equal to delta U plus W. Yes or no? So delta U equal to 0 as it is a cyclic process. So delta U equal to 0. So what is the value remaining? Q equal to W. Okay. So Q means whatever the amount of heat we have given, that is called as the Q. That will be equal to the net work, the work done. Whatever the work done produced by the body, that will be the work done. Okay, so Q, whatever the heat we have supplied, that will be directly transferred into work done. There will be no increase in the internal energy, the particular cyclic process. The question, how the question will come, that this type of how the question will come, that means if a question is come, what is the first law of thermodynamics, state and explain first law of thermodynamics, as well as how the first law of thermodynamics can be applied in the cyclic process. So these were the 3 marks question, 2 marks for the, we have to explain the what first law of thermodynamics, then after you have to what use how the first law of thermodynamics can be used in the cyclic particular process. Okay, so then comes to, this is the what application of the first law of thermodynamics in the cyclic process. Then comes to then first law of thermodynamics, how can you apply the first law of thermodynamics in the isolated system? Isolated system. Isolated system means, first of all you should have to know about what is isolated system, what is the definition of isolated system. First of all you have to know, then after you can what put the first law of thermodynamics in the particular isolated system. A system which can neither do work or nor give the what not take the heat energy, that is called as the isolated system. That means if there is no connection between the system and surrounding, okay, there is no connection means heat cannot be transferred from the system to the surrounding, then the particular system is called as the isolated system. Isolate means separate. Isolate means separate. Okay, so in the corona period also you have see that isolation beds are created. Isolation means it is a separate, you have to keep separated distance, that means you have to keep separate, that means that is called the isolated system. Okay, in this particular system what will happen, the what the whatever the heat we have supplied, that means q will be 0. Q means whatever the heat that cannot be entered throughout the system. If the particular system is a system, and that will be what separate from the surrounding, no connection between the system and surrounding. If it is a surrounding and this is a system, if there is no connection between the system and there is no connection, no connection between the system and the surrounding, then this particular system is called as the isolated system. Okay, and if this in this particular system, if there is no connection, that means whatever the heat we have supplied, that cannot be entered through the system. Yes or no? So Q equal to 0. Q means that the total amount of heat will be whatever the heat we have supplied, that will be equal to 0. So if Q equal to 0, there will be also no work done by the system. That means W equal to also 0 in the particular isolated system. In the isolated system, what will happen? Q equal to 0 as well as the W equal to also 0. So then if we apply the first law of thermodynamics, if you apply the first law of thermodynamics, if we apply the first law of thermodynamics in this, then what will happen? First law of thermodynamics means what? dq or q equal to what? Delta U plus W. Yes or no? So delta, that means q equal to 0, as it is an isolated system. So q equal to 0 as well as the W equal to 0. So what will happen? Only delta U equal to 0 in this particular system. What will happen? Delta U means the change in internal energy will be 0. Okay, then comes to third one is the isobaric process. Isobaric process means first of all you have to understand what is about isobaric process, what is the definition of isobaric process, and then after you can use how can you use the first law of thermodynamics in the isobaric process. As thermodynamics is one of the important chapters, so first of all you have to cover the thermodynamics. Then after we will go the whatever the chapter that are remaining, that means the thermal property of matter as well as surface tension. We will complete that after that. Okay. So thermodynamics means first law, second law, completely we will complete the particular topic. Then after we will go the previous topic. Okay. So isobaric process. Isobaric process means what? If a particular process in which the system, that means the pressure will be constant. Okay, that means if the pressure throughout the system will be keep constant, the pressure equal to constant, in that particular system is called as the isobaric process. That particular process is called as what? Isobaric process. Isobaric process means what? A process taking place at a constant pressure. If a process that is taking place at a particular constant pressure, that will be called as the isobaric process. Okay, I will whatever the doubt, those who are raising their hand, I will ask, that means the last 5 minutes you can clear your doubts. Okay, so don't raise your hand in between the class. So if P equal to constant, P equal to constant means pressure throughout the system, if it is a constant, then the process is called as the isobaric process. This type of process is called as what? Isobaric process. In this process, how can you find out the what? How can you apply the first law of thermodynamics in the particular isobaric process? Okay, so I will know that the first law of thermodynamics means what? Q equal to delta U plus W. Del Q equal to what? Delta U plus W. How can you apply the first law of thermodynamics in this particular isobaric process? And we know that one formula, that means Q equal to heat equal to what? Mass of the system into latent heat. That's this definition you have learned from the 10th class. I think the heat equal to mass of the system into latent heat. This is the definition of Q. Q equal to mass of the system. That means if a substance having some mass M, may M, and a latent heat of the particular substance is M, L it is given. So Q equal to M into L. Okay, so this is the amount of Q, whatever the heat is supplied to a system, that is equal to M into L. Okay, so in this particular system, what we'll know that if Q equal to M into L, then we have learned that what the we have one what formula, that means W. How can you find out the work done throughout the system? Work done equal to what is the formula of work done? Force into displacement. Yes or no? Force into displacement. So force equal to pressure into area into displacement. If the, I'm just making the figure, if some gas molecules are there in this particular container, okay, and we are just what giving the heat from the downward portion, that means from the bottom portion we are just giving some heat. Then after, what is the work done? If the particular by the expansion of gases will be there, then what is the work done throughout the particular system? So W equal to F into dx, dW equal to F into dx. So that means pressure equal to force, force equal to pressure into area into dx. So that means P into, in place of A into dx, A means area into dx. Okay, so in place of that we can write a dv also. Okay, because area into length, it will be volume. Yes or no? So dw equal to pdv, or whatever the work done that will produce, that will be equal to pdv. Okay, so that means if you want to apply the first law of thermodynamics, first law of thermodynamics, what does it tell? That first law of thermodynamics tell that Q equal to delta U plus W. Yes or no? If you want to find out delta U, that means Q minus W. Yes or no? Q minus W. Okay, and particularly in the same way, you can explain if the particular at the freezing of, if one formula I have written, that means Q equal to M into L in the particular expansion time. In the expansion time means if I giving the heat to a body, in that particular condition, Q equal to M into L. In the positive case we are taking, and in the particular compression time, that means if the particular, if water freezes into ice in this particular process, what will happen? So if you just cool down the temperature, if you just fall down the temperature in which what will happen? Whatever the heat that will produce, Q equal to minus into ml. In the negative sign, it will be produced. That means if you are just giving the heat and if the temperature will rise, in that condition, Q equal to ml. Normal definition, if the temperature will fall down, in that particular condition, Q equal to minus m into L. Okay. So if you just put it Q means minus ml minus what? PdV. PdV minus ml minus P into delta V, or you can write PdV also. You can write, if you are writing delta, so you just use the delta symbol also here. So delta U equal to what? Minus ml minus PdV. This is the what? Application of first law of thermodynamics in the particular isobaric system. We will also discuss what is this particular system in the next chapter. I think it is given what is isothermal process, what is isobaric process, what is isochoric process. All these things we will discuss in the next chapter. It is given, but the application is given in this chapter, so we will discuss. Next process is isochoric process. Next process what? Isochoric process. What does it mean? Isochoric. Isochoric means I'm just telling the definition. What is the definition of isochoric process? Isochoric process means if in a particular process, if the volume remain constant, if the volume of the system remain constant throughout the process, then this type of process is called as the isochoric process. Okay. So I'm again repeating, if the process takes place in the system at a constant volume means volume remain constant. Okay, if volume remain constant, then delta V will be equal to 0. Delta V means change in volume. There will be no change in volume. So delta V will be 0. And you already know that one definition I have already proved, that means W equal to PdP into delta V, or you can write P delta V or P delta V. That means the work done formula is what? If if you are just supplying the heat to a system, in that particular condition, work done equal to W equal to P into delta V. And delta V, as it is 0, so work done will be also 0. Yes or no? So in this process, what will happen? W equal to 0. Okay. So is in this particular process, what will happen? W equal to 0. So if we apply the first law of thermodynamics, if we apply the first law of thermodynamics, what does it tell? That Q equal to what? Delta U plus W. Yes or no? So as W equal to 0, so what will happen? Q equal to delta U plus 0. So that means whatever the heat we have given to a system, that will be used to increase the internal energy. Q equal to delta U. In this particular isochoric process, what will happen? Whatever the heat you have supplied to a system, that is used to increase the internal energy, delta U, it is used to increase the internal energy. That means Q equal to delta U. Okay. Then comes to last, the two processes are there. One is isothermal process. What will happen in the isothermal process? Isothermal process means what? Isothermal process. Okay. So what is that? What does it mean, isothermal process? What is the definition for isothermal process? What is the definition? Definition of isothermal process tells that if the process is carried out at a constant temperature, if the temperature of the system remain constant throughout the process, if the temperature of the system remain constant, then that process is called as the isothermal process. Okay. If the temperature of the system remain constant, okay, constant throughout the process, then this process is called as what? Isothermal process. Iso means it is a constant, and thermal means temperature. Okay. So if during a process takes place in the particular system, the temperature remain constant, then this process is called as the isothermal process. This process is called as what? Isothermal process. In this particular isothermal process, the temperature will what? Keeps constant. If the temperature will not rise, then what will happen? Then there will be no change in internal energy. Whatever the internal energy the body will have, that will keep constant. Okay. If you will not, that means if the temperature is not rising, if you are supplying the heat, but temperature of the inside the system, that is not rising, so then what will happen? Then the internal energy, change in internal energy equal to 0. Okay, so that will be delta U equal to 0 in this particular process. In this process, what will happen? Delta U means whatever the change in internal energy of the system, that will also equal to 0. Okay, then just see that if you apply the first law of thermodynamics, what does it tell? That the first law of thermodynamics tells that what q equal to delta U plus W. Yes or no? So delta U equal to q minus W. So as the delta U thing equal to 0, delta U equal to 0, as the process is an isothermal process, in this process delta U equal to 0, as the delta U equal to 0, then what will happen? Q minus W equal to 0. So Q, whatever the heat we have supplied, that will be equal to W. Okay. So if in the particular isothermal process, what will happen? Whatever the heat we have supplied to the system, that is you that will be directly converted into work done. That will be directly converted into work done if the process is the isothermal process. Remember this point. If first of all you should know about the first is what is isothermal process. What is isothermal process? The if the in the particular process, if the temperature remain constant throughout the process, if the temperature is just keeping the constant, then this process is called isothermal process. Then how can you apply the first law of thermodynamics in the isothermal process? First law of thermodynamics tells that q equal to delta U plus W. Okay, so as particular in the if the temperature will not rise, then whatever the internal energy, that will also not increase. Okay, so delta U equal to 0, as the delta U equal to 0, then what will happen? Q minus q equal to delta U plus W. So delta U equal to q minus W, and in the particular isothermal process, what will happen? Q delta U equal to 0. So if it will be 0, then what will happen? Q minus W equal to 0. So Q equal to W. Whatever the heat we have supplied, that will use to directly the increase, sorry, to directly convert it into work done. Okay. So these are all about the isothermal process. Next one is the adiabatic process. We will discuss the 60th period. We will discuss in the 60th period what is adiabatic process and how can the what first applying the first law of thermodynamics in the adiabatic process.